So I took the noise out of this video so I can explain to you much better, and you don't hear all the noise in the background. So I'm gonna give you just the basic explanation on this video. Okay, so right now we're looking at the condensing pumps. These pumps will pump water to your condensing side of the chiller, and it will also pump water to the cooling tower to cool down the water. These are the drives. Two of them are for the two pumps that I have on this one for the two condensing pumps, and the other two are gonna be for the chill water pumps. Right now we're looking at the piping. As you can see, one side is the chill water, and the other side is the condensing waters. See, condensing on the left, chill water on the right. And these are all our pipings on this, and I'm gonna show you the horsepower on this motor, which I think is 75 horsepower when I looked at it. And you can kind of identify by the size what kind of horsepower motor you will have. But these are the chillers. These are centrifugal chillers, as you can see. On this side, this is the other chiller, and if you see on this side, I'm showing you this tank, and this tank is the condensing side of the chiller, and that one over is going to be your evaporator. That's where your chill water goes through. You cool the water through the evaporator, and this is the condensing side on your chillers, centrifugal chillers. Now I'm gonna show you a video of the cooling tower, so you can have an idea how the cooling tower looks. All right, so now we're looking at the cooling tower in this same building. As you can see, there's the motor right there, and on top you have a big old fan on top of the cooling tower. Right there's a bypass valve that you're gonna have. That's gonna open up depending on the demand you're gonna have. That's where your water comes from the top and runs down through there. That's how you cool down your condensing water. That's a ladder. So if you need to service the cooling tower, change belt, you can go through that ladder. But this is how a cooling tower looks. You might be familiar, you might not. So hopefully this can give you a better idea if you haven't seen one. All right, so this video is not going to be about refrigerant cycle. This video is going to be about how do you cool a building with a cooling tower. So we're gonna talk about the water cycle on the condenser side and on the cooling side, and how the cooling tower and the chiller operates with those two things, the chiller and the cooling tower. All right, so what are you seeing right now is the same building where those cooling towers and that centrifugal chiller set. They told me that the school was hot, so I didn't have any issues on my chillers or cooling towers. It was just the signal problem that I had. So what I'm gonna do here is we're gonna cool those areas. We're gonna cool those rooms. And in this video, I'm gonna show you how a cooling tower and a centrifugal chiller does it. I'm gonna try to explain it the best I can, step by step, so you can have a good understanding on how it works. So now we're looking at a specific area, and we're gonna go deeper into this and look at a specific room and see how we're gonna have to cool, or how this room is gonna start cooling through the cooling tower and the centrifugal chiller. Okay, so what we're looking at is now the VAV box, and I'm gonna show you how this operates. This is a VAV box, and this is how you cool down a specific room, or sometimes even an area, a hall, like I said, or any room. So right now, let's look at this. Is our heating, which we're not gonna talk about the heating, but that's how you provide heating from the boiler. So how do you provide cooling? Well, your cooling, you will provide it through here, through this damper. It's either gonna ask on, right now it's asking 100% open, depending on the demand. This is your blower, and that's how you push that cooling through for your room. In this case, you need the blower. That's now your return. You have your return on that side, and that's where you get the temperature from there. As you can see, it's 58.4 on this time. Remember, this is a screenshot. So at the time that I was looking at it was actually live, but right now it's a screenshot. Your air goes through there, and then you have to push it through your blower, and it keeps going. That's your cooler. We're talking about cooler, and then it goes out through your supply or to your vent, and that's how you cool in a specific area. Now, where are we getting that cooler from? And we're gonna talk about that in a little bit, because your cooler, you get it from this air handler over here. In this case, it's 1-3, and that's how you get your cooler. And it tells you right there the supply cooler temperature that is coming from your air handler unit. In this case, is 1-3. On this VAV box, you have to have your blower running at all times for cooling and heating. On some other VAV box, you don't need the blower. Okay, so what I was saying about the VAV box is you don't need the blower running for cooling at all times in some VAV boxes and some different type of systems. And for heating, you can also have electric heating instead of boilers or hot water. But anyways, let's talk about the air handler unit, so you know where you're getting the cooling from. This is your air handler unit right here. This is what provides the cool air to your VAV box right here. This is what gives you the cooler again to your VAV box. Now let's see the air handler unit with a little more specifics. On this side over here on the left, you are going to have your outside air. This is your outside air. You provide fresh air. On top, you're gonna have your return that comes from the rooms, from the area that you're cooling. That's your return air. Okay, now that we see the return air, we're gonna talk about the other specifics of the air handler. Let's talk about it. Right now, I'm gonna show you right here your filter. I'm going to show you your heating coil, your cooling coil. You're gonna have your blower, your supply air temperature, and you also gonna have some other specifics right there. You're gonna have CFMs, return temperature, etc., etc., etc. So let's see where you get your cooling from. What cools down your air in this air handler, and this is what we're gonna talk about right now. Okay, so this coil right here, that's where your chill water is. You bring chill water from the chiller to this coil. This valve will open or close. Right now it's 100% open, but sometimes it will be 50 or less, or whatever the demand is. You also get your blower. That's, you're gonna push your air through there after it's already passed through your cooling, and then provide it to your VAV box right here. And that's how you provide cooling to a specific room or area. That air goes through down there, and then it goes through your fan, and then it goes outside to your supply or your vent on the VAV box. If you see in the VAV box, that's where you have your damper, and that's where your air goes through. Hopefully you're having a better understanding on how this operates and how you provide cooling to those specific areas or to that specific room. One air handler will feed several rooms or a big area. So now we're looking at the chillers, and we're gonna talk about the cooling side of the chillers. In this case, you have chiller number 1 and chiller number 2. You also have chill water pump 1, chill water pump 2, and I'm gonna explain the water cycle and how it runs. In this case, only chiller 2 and pump 1 are the ones that are running. So let's go through it. This is the same building that we've been looking at for the VAV boxes and all of that. So we got chiller number 2 running, and this is where your water goes in, your chill water. And I'm gonna explain to you how the water will run through this system. Again, this is the chill water side, not the condensing side yet. So we got chiller number 2 running, and then pump number 1 running. This will put your water into your evaporator side. In this case, we're talking about the evaporator in that tank that I circle. That's where your evaporator is, and that's how you cool down your water. Your water is gonna be running. You're gonna have a return and a supply. Again, a return and a supply. Supply is what you give to the building. Return is what you get back from the building or from the air handlers. So from the air handlers or the building, you're gonna have a chill water return that is going to run through the left side on this lines over here. Your return goes through there, and that's coming from the air handler units. Yeah, your return comes from the air handler units, or if you want to call it from your building, then goes through this pump in this case, and then to your evaporator. Because remember, only pump 1 is running, and your chiller 2 is running, and it goes through there, and then it goes back to your building. That's your chill water supply to the building. It goes out through that line coming out of the chiller bundle or chiller evaporator, and it goes to your building. So right now I'm gonna show you some valves that you're gonna have. This is gonna be your supply valve. It's gonna open or close depending on the demand. Also, you're gonna have a bypass, and it's gonna do the same thing depending on the demand that you have in the building. I think those are the only valves that I see. You have sensors as well that are gonna read temperature, supply, return, and all of that. I'm gonna show you again how the water cycle works from your air handlers. It comes through here. That's coming from your air handler. It goes to pump number 1, and now it goes to chiller number 2. It goes to your evaporator. You cool down the water, and now it goes out from your evaporator into the building, and that will be your supply to the building. You also have your bypass, and your water runs through here on this line, and then it goes back to the chiller. In this case, only 20% of the valve is open. So this is it for the cooling side of the chiller. Alright, so I put these 2 pictures together so you can have a better idea how the water cycle runs from the air handler to the chiller, or from the chiller to the air handler. You return from the air handler, goes here, then it goes to your pump first, and then your chiller, then it goes back to your air handler or building, however you want to call it, and then it goes to your coil in the air handler over here. That's where it comes in and it comes out. Then it goes back again, like I said, as you can see in the linings, to your chiller, and then it comes from your chiller to the air handler. This is just to give you a better picture on the water flow through the system. As you can see, it comes from the chiller, goes to the coil, then it goes back to the plant. Hopefully this helps you have a better picture on how the water runs through your system. Alright, so last but not least, we're gonna talk about the condenser side of the system. Uh, I put cooling side as well. It's right here, which we already talked about and we already look at it. And now we're gonna look into the condenser side of the chiller system and cooling towers, which is over here in the top of the picture. So you can get an idea of how the water cycle works on your chillers on the condenser side. The only difference that there is between these chillers, centrifugal and cooling towers, from the air condensing chillers is that instead of using condenser motors and air to subcool our refrigerant, we use water and the cooling tower that's gonna help us with the subcooling on the condenser side. So here we got our condenser, we got our pump over here, and two cooling towers. Like I said, the only difference in this one is that we're gonna use water to subcool our refrigerant instead of air. In this case, chiller 2 is running and pump 1 is running and two cooling towers are running. Our water flow is gonna go through this line from the condenser, which is gonna be full of water. Let me explain to you exactly how it is. So let me do it better. This is our condenser, which has the water. Water is gonna flow through this line, and it's gonna go all the way to a line. Then it's gonna go on top of our cooling towers, both of them. Then the water is gonna it's gonna run down through the fence of the cooling tower. That fan is gonna be running, and it's gonna be lowering the temperature or cooling down our water. That is gonna go back through this pump, and it's gonna go all the way back to our condenser on the chiller right there. So in our condenser is where the subcooling is happening. Instead of using air, we're using water. Okay, now these fans over here are gonna be running, and those are gonna be running according to the demand of the system. So they can be at 30%, 20%, 100%, depending on the demand of the system. And they help to cool down the condenser water. We got two supply valves to the cooling towers, two bypasses on the cooling towers, and a supply valve on the supply from the chiller. You also have sensors that are gonna sense the temperature, water temperature, the return and the leaving temperature from your chiller and your cooling tower. I hope this video has helped you to have a better understanding of how a cooling tower and centrifugal chillers work and how they operate, how the circulation of the water works, and how do you provide cooling from your chillers to your building, to the rooms and specific areas. Maybe there's some points that I didn't cover. I hope I did explain myself the best I could, so like I said, so you could have a better understanding. I know a lot of y'all watching might already be familiar with this. This might be new stuff for you, and if you ever are in a situation where you have cooling towers, hopefully this video can be helpful. Again, thanks a lot for watching this video. I really appreciate your support. If you can like and subscribe to my channel, I really appreciate it. Now I'm gonna leave you with a live view of how the system operates. Again, thank you so much. I'll see you in the next one.